dear students. In today's class we shall be solving some questions from the miscellaneous exercise of matrices. So the first question, matrix A is given and we have to show that some expression is equal to the right hand side where n is a natural number. So I write down what is given to us. Matrix A is a square matrix expressed this way, and we have to show that A into I, this is identity matrix, plus B into matrix A to the power n is A to the power n into identity matrix plus n A to the power n minus 1 B into matrix A, where it is understood I is identity matrix and we have to prove this result for all natural numbers. Small a and small b are some scalar quantities. So we are going to prove this or show that the two results are equal using the principle of mathematical induction. This is one principle which you have studied last year in class 11. So the principal application of the inductive process basically involves 3 steps. The first step here, we put n is equal to 1. The left hand side, this left hand side is AI plus BA and n is 1. The right hand side, n is 1. So A to the power 1 minus 1 BA, and any scalar quantity raised to power 0 is 1 itself. So we see here that the left hand side is equal to the right hand side, and hence we can say that the P1th statement is true. The first step is done. Step 2, here we put n is equal to 1. This is the inductive step. So here we assume that the pkth statement is true. So if the pkth statement is true, we also need to know what is the pkth statement. So in this equation, replace n by k. Left side is this, and on the right side we have this expression where k is a natural number. Then step 3, in the third step we put children, this is n is equal to k. Okay, so put n is equal to k plus 1. Now in this step we have to prove that the pk plus 1th statement is also true. Now to prove this statement, we also need to know what is pk plus 1th statement. So in this equation, replace k by k plus 1. K plus 1i plus k plus 1 a to the power k b a. And now we'll start from the third left hand side and show that it is somehow equal to the right hand side. So starting from the left hand side, the expression that we have is AI plus BA to the power k plus 1, which can be written as this way using laws of exponents. This expression which we have obtained here can be used over there. So I am just underlining this, replacing this term by this expression on the right hand side. We get a to the power k into I plus k a to the power k minus 1 b into a into ai plus ba. Let's perform the multiplication. Multiplying this term with these two elements, we get a to the power k plus 1 I plus a to the power k b I into a. Let us multiply this element with these two elements. So we'll obtain k a to the power k b a I plus k a to the power k minus 1 b square a square. Now the simplification has to be done keeping in mind the required result. We already know this has to be the result. So as you can see here, the first term has already been obtained, a to the power k plus 1 I. Simplifying this term, it is a to the power k b. Identity matrix multiplied by any matrix is the matrix itself, and over here k a to the power k b, once again this is matrix A, plus the next term, which is this. So in these two terms we can take common elements, and the common elements are a to the power k b into a. So we are left with 1 plus k. So this term is same as this, k plus 1 a to the power k b into a. We notice here that we are obtaining this additional term here, which is not required. So how do we get rid of this additional term? So for this, let us perform here, find out here a square. So this is matrix A, 0 1 0 0 multiplied by itself. So when you find out a square, you will see that this is a 0 matrix, and a 0 matrix multiplied by anything gives us a 0 matrix. This is not 0, this is 0 matrix. So finally we have obtained the result. We started with the left hand side and we have shown that it is equal to the right hand side, and therefore pk plus 1 is true. Since we have used here the principle of induction, we can also write down here, hence by the principle of mathematical induction, the p nth statement, which is this equation is true for all n which is a natural number. So we have done question 1, question 2, question 3 and question 12 are of similar kinds. Okay, then question 4 and 5 are also similar. I am going to take up question 5. So fifth question, matrix is given. We have to show that this matrix is symmetric or this matrix is skew symmetric according as A is symmetric or A is skew symmetric. So in simple words, we have to show that this is a symmetric matrix if A is symmetric. Likewise, it is a skew symmetric matrix if A is a skew symmetric matrix. So this information is given to us. So I'll write it down here that we are given A is a symmetric matrix, and a symmetric matrix means that its transpose is the matrix itself. Now, to show that this is symmetric, we have to show that its transpose is same as the matrix. This is what we have to show. So let's start from the left hand side. B dash AB and its transpose. Because there are three matrices, I am considering this as one matrix. You can choose B dash A also as one matrix. So if we have this way, two matrices B dash and a matrix AB, using properties of transpose, this is equal to AB transpose multiplied by transpose of this. Using the property of transpose of matrices, for the product of matrices it is B transpose, A transpose into this. We have basically used these results. AB transpose is B transpose into A transpose, and transpose of a transpose matrix is the matrix itself. So these results we have used here. And since A is symmetric matrix, using the result, we have B transpose A into B. This is same as the right hand side. You know, at any point of time, this dash can be replaced by a transpose, so there should be no confusion. Dashes means transpose only. So this is the result we wanted, we have shown here. So we have shown that this matrix is a symmetric matrix only if A is a symmetric matrix. Now moving on to the second part. In the second case, we are given that A is a skew symmetric matrix. A skew symmetric matrix means the transpose is equal to the negative of the matrix. Here we have to show that transpose of this is equal to minus of B dash AB. This is what we have to show. So starting from the left hand side, transpose of this product. Here again I will consider AB as one matrix. So using properties of transpose of matrices, AB transpose into transpose of B transpose, using the similar properties here, B transpose into A transpose into B. Since we know A transpose is minus A, replacing this by minus A, we get this. This is what is given in the right hand side. So we have proved the result. Therefore we can say that B dash AB is a skew symmetric matrix if A is also a skew symmetric matrix. So the next question is question number 7. 7 and 9 are similar kinds of questions. So 7, we are finding out here value of x. The given matrix equation is a matrix with 3 elements multiplied by this matrix which is again multiplied by the matrix with elements 0 to x, and on the right side this is non-zero, this is a 0 matrix. So here I am just going to cross check whether this multiplication is possible or not. So order of this matrix is 1 by 3, order of this matrix is 3 by 3, number of columns is equal to number of rows, so matrix multiplication is possible. And when we multiply the first two matrices, we will obtain a matrix whose order is 1 by 3, which will be multiplied by this matrix. The order of this matrix is 3 by 1. Again, matrix multiplication is possible, and the resultant will be a matrix of order 1 by 1. That means it has one element, and that element is 0 because we are already given it's a 0 matrix. So let's find out this product. So the first row multiplied by this is 1 plus 4 plus 1, 6. The next element is 2 plus 0 plus 0. Next element is 2 plus 2, 4. Now performing this multiplication, It is 6 into 0, 2 into 2, 4 plus 4x, which is equal to 0 matrix. Equality of matrices, so comparing the elements and simplifying, we get x is equal to minus 1. So next we take question number 8. Question 8, a square matrix of order 2 is given with elements 3, 1, minus 1, 2, and we have to show that a square minus 5a plus 7i is again a 0 matrix, and then we have to use this result and find out a to the power 4. So let's start here from the left hand side. A square matrix multiplied by itself five times matrix A plus 7 times identity matrix of the same order. So performing this multiplication, we get 9 minus 1, 8, 3 plus 2, 5, minus 3 minus 2, minus 5, minus 1 plus 4, 3, minus, performing the scalar multiplication, 15 minus 5, 5, 10, and over here we have this matrix. Adding and subtracting corresponding elements, 8 minus 15 plus 7 gives us 0. Then minus 5 minus of minus 5 plus 0 gives 0. 5 minus 5 plus 0 is 0. 3 minus 10 plus 7 is 0. So finally we have obtained a 0 matrix. So this part of the question is done. Now using this information only, we have to find out a to the power 4. So from this equation we can write down that a square is 5a minus 7i, and a to the power 4 can be written as a square into a square, which is 5a minus 7i into 5a minus 7i. Now performing this multiplication, we have 25a square multiplying 5a with these two elements, we have minus 35ai. Then next we have minus 35ia plus 49i square. So 25a square, because we know a into I is a, I into a is also a, so simplifying these terms we get 70a, and I square is equal to I, so 49i. Now let's substitute values here. 25 a square. A square we have already calculated. This is a square. 8, 5, minus 5, 3, minus 70 into a, which is 3, 1, minus 1, 2, plus 49 times identity matrix. So this is 200 minus 125, 125, 75, minus multiplying by 70, 210 minus 70, 70, 140, plus 49, 0, 0, 49. Simplifying here terms, 200 minus 210 plus 49 will on simplification give us 39. Next, minus 125 minus of minus 70 is plus 70 plus 0. So this gives us minus 55. This element is 125 minus 70 plus 0, positive 55. And the last element, 75 minus 140 plus 49. So performing this, what do we get? Minus 16. So this way, using this information, we have found out the fourth power of matrix A, which is this. So next is 11th question. Find out a matrix X. This is not a variable. A matrix X when this matrix equation is given. The matrix on the right hand side is so to find out matrix X, we need to know what can be the possible order of X. So suppose order of X is m by n, order of this matrix is 2 by 3, and the product matrix is also of order 2 by 3. So you know this multiplication is possible only when number of columns is equal to number of rows. So from here we get to know n is 2. And the product matrix will be of order m by 3. So comparing this with m by 3, we get to know that m is equal to 2. So the order of matrix X is 2 by 2. So suppose matrix X is given by these elements. The other matrix has elements 1, 2, 3, 4, 5, 6. And on the right hand side, this matrix is given. So let's multiply here. We get A plus 4B, C plus 4D, 2A plus 5B, 2C plus 5D, 3A plus 6B, 3C plus 6D, which is equal to this. The two matrices are equal, so comparing corresponding elements, A plus 4D is minus 7, 2A plus 4B, 2A plus 5B is minus 8, 3A plus 6B is minus 9. Let these be equations 1, 2 and 3. Comparing the second row, we have C plus 4D is 2, 2C plus 5D is 4, 3C plus 6D is 6, and these are equations 4, 5 and 6. So let us solve these two equations. Any two equations can be taken. I am taking the first two and multiply equation 1 by 2. So solving first and second equations, multiplying by 2, we get 2A plus 8B is minus 14, and the second equation 2A plus 5B is minus 8. Subtracting corresponding elements, so we have here 3B equal to minus 6, therefore B is minus 2. One element we have found. Let us substitute this value of B in the first equation only. So the first equation is A plus 4 times B minus 8, which is equal to minus 7. So A is equal to 1. Now we have got value of A and B. We'll put these values in the third equation and just cross check have we found the correct values or not. So the left hand side is 3A plus 6B, which is this, minus 9, which is equal to right hand side. So we know values of A and B have been correctly found. Likewise, let us solve equations 4 and 5. Once again multiplying equation 4 by 2. So here we have 2C plus 8D is 4 and 2C plus 5D is 4, and subtracting we get 3D is 0, therefore D is 0. Substituting D in the first equation only, fourth equation, C plus D is 2 and therefore we obtain C is equal to 2. And for cross checking, let us substitute these values in equation 6. The left hand side is 3C, which is 6, plus D, which is 6, and this is equal to right hand side. So we know we have found values of C and D correctly. So the solution does not end here, because the question asks us to find out matrix X, which we have supposed to be A, B, C, D. Now substituting here, we get A is 1, B is minus 2, C is 2, D is 0, and you can see this is a matrix of order 2 by 2.